Hi, Rodolph here. Let's say you started learning programming. Then you probably know about variables, conditionals, and loops. That's great, because now you can code up some really useful and cool functions like this banana count function here that counts some number of bananas n, then celebrates once we count our last banana. I know it seems silly, but trust me, that's a startup company in the making. At this point, you could probably start coding up anything you want, but you might have also started to hear about something called recursion and recursive functions. But what exactly is all this? Well, buckle up, folks, because today we're going full speed into understanding and thinking about recursion. And, if you couldn't tell already, there's going to be a lot of bananas. Stick around, because this is episode 1 of Algomations. So in the context of programming and computer science, recursion is where we solve a problem by solving smaller versions of the same problem. But what does that exactly mean? Let's look at an alternate version of the banana counter from before, which does the same thing as our original banana counter. It counts some n number of bananas, but it does so without using any loops. The secret? Moving variables around and self-referential function calls. You may have noticed that this banana counter takes in 2 inputs rather than 1. N, representing the total number of bananas to be counted from before, and b count, the counting variable that we had inside of our original banana counter. Having b count as an input rather than an internal or local variable, and making strategic calls of banana counter is the key to loopless counting. So let's see how this banana counter would count up 3 bananas. Setting n equal to 3 then is a good move. But what about b count? Looking at our looping banana counter, we might be inclined to put in b count equals 1. But you could see how that might not work out so well with our first if statement. In that case, we would only count 1, regardless of however many bananas we put in. Worse, there would be no celebration because 1 does not equal 3, and that's a big sad right there. So what number should we use for b count? You can pause the video here to think and guess, but given that b count is our counting variable, which has to count all numbers from 1 to 3, we want to be sure that our banana counter counts our last number, so let's go for 3. But if b count starts at 3, the last number, then how can banana counter count up from 1 to 3? Let's run through our program to find out. Since 3 is greater than 1, we'll immediately go to the else case, where we see that banana counter calls itself. That's right, rather than having all the numbers counted up in one call, like with the loop banana counter, this banana counter calls itself, getting its clone, whose b count is set to 2, to count the first 2 bananas before it counts banana 3. Meanwhile, the clone, like its caller, sees that its b count value is greater than 1, and calls itself, getting its clone with b count set to 1 to count the first banana before it counts banana 2. Finally, this newest banana counter clone doesn't call itself, as its b count value is equal to 1, and instead counts out 1 per the first if statement. It then checks to see if its b counter value happens to be equal to n, as that would indicate all bananas have been counted, and the celebratory message can be sent out. However, 1 does not equal 3, so no celebration here. From there, the first banana counter clone sees that its clone has finished counting 1, and then counts out 2. That same banana counter then checks to see if its b counter value happens to be equal to n. Unfortunately, 2 also doesn't equal 3, so still no celebration yet. Seeing that the second banana has been counted, our original call of banana counter counts out 3. Then, seeing that all n equals 3 bananas have been counted, it shouts out, "Let's go bananas," and we celebrate. Woohoo! In going through this recursive banana counting process, we could think of our function here like a Russian doll, where each of the n dolls, representing a function call, shouts out their number starting from the innermost doll and ending with the outermost one. This makes our alternate version of banana counter a recursive function, because it calls upon itself to solve the same smaller problems involved in solving the main problem. In our case, our problem is counting b equals 3 bananas from 1 to b count. To do that, we would have to count every number before b count from 1 to b count minus 1, or 2, then count out b count, which is 3. Then, in carrying out our subproblem of counting from 1 to b count minus 1 equals 2, we have to count every number before b count minus 1, which is just 1, the very first number we count. For a larger number of bananas, this process would continue on for b count minus 2, b count minus 3, and so on and so forth until we reach 1, like we did just now. While this banana counting logic seems straightforward enough, this recursive way of thinking can be used to solve many problems in the programming world, from calculating things like factorials and Fibonacci numbers to change-making, scheduling events, sorting, pathfinding, the list goes on. We'll tackle these applications in future episodes, but for now, we'll end this first episode here. Hopefully, this short video has given y'all a basic idea of what recursion is, but don't worry if you don't fully understand it at this point. We'll really start building up our recursive thinking skills in the next episode, where we'll learn how to program our own recursive functions. Thanks for watching. I hope you all enjoyed this first episode of Algomations, a little animated series in the works. We're just getting started here, so if there's any other programming concept you want me to cover and animate in future episodes, let me know down in the comments. Likewise, if you have any questions about this video, you can also leave those down in the comments and I'll answer them as best as I can. While you're waiting for the next episode, make sure to like and subscribe, and I'll see y'all next time. Bye!